Module 13 study guide. As always, please try to complete your study guide first before watching this video. Try to get all these answers on your own. Only use this video to check your answers or maybe give yourself a few pointers on ones that you might have forgotten how to do. So, solving absolute value equations. This is going to be on your test on Friday. And you've been working on this in Delta Math. This is what we did last week, and it was part of our quiz last week as well. So when we're solving absolute value equations, we first need to make sure that the absolute value portion of the expression is left alone. There's nothing by it. Okay. And in number one, that is the case. So once we get that isolated, then we can just split it. Okay, remember, one of them is just going to be the expression inside of the absolute value bars equals whatever number's on the right hand side, 9, and the other one would be the expression inside of the absolute value bar equals the opposite of the number that's on the other side of the equal sign, which in this case would be -9. Solve both of these equations, and you would get n equals 5 and n equals -13 as your answers. -13 and 5. Let's move on to number 2. Again, nothing on the outside, nothing by the absolute value equation or the absolute value expression, so we could just immediately split it up. So we have -4 plus r equals 8, and -4 plus r equals -8. Solve both equations. You get r equals 12, and you get r equals -4. So your answer, your solution set is going to be -4, 12. That's it. Same with number 3, nothing by the absolute value bars, so we could just immediately split it. M over 3 equals 2, and m over 3 equals -2. So the way we'd get rid of division is by multiplication. We'd have to multiply both sides by 3. Multiply both sides by 3. And if you do that, you get m equals 6 and m equals -6. So your solution set is going to be -6, 6. Next, number 4, easy. Again, once again, nothing by the absolute value bar, so we could just immediately split it. That would be x plus 3 equals 4, and x plus 3 equals -4. We'd have to subtract by 3 on both sides of both equations. And if you do that, you get x equals 1 and x equals -7. So your solution set would be x equals -7, 1. Okay, now we have something that we'd have to get rid of before we could split it. So remember, your first step is to make sure that your absolute value bars are by themselves. That part of the expression is isolated. If not, you have to isolate it. You'd have to get rid of this 5 first before you can split up our absolute value equation. And the way we'd get rid of this 5 is inverse operations. This means 5 times the absolute value of v plus 5. So to get rid of multiplication, we would divide by 5 on both sides. If you do that, you get absolute value of v plus 5 equals 11. And now you go ahead and split it. We get v plus 5 equals 11. And v plus 5 equals -11. And if you subtract 5 on both sides of both equations, you end up getting v equals 6. And v equals -16 as your solution set. So we have -16, 6. Same with number 6. Number 6, you'd have to get rid of the 6 first by multiplying it by 6 before you go ahead and split it up. And that'll give you the absolute value of 7x, because these would cancel, equals 6. Now we could go ahead and split it up. It would be 7x equals 6. 7x equals -6. You have to divide both sides by 7 of both equations, and your two solutions would be x equals 6/7 and x equals -6/7. And that's it. Okay? For this one, I want to change this to a positive 3. Let's change it to a positive 3, if you will. So what you would have to do first is you would have to divide by positive 3. And if you divide by positive 3, that would leave you with the absolute value of 8x equals negative 16. I want to stop right here because this messed you up in the quiz that we took last week. A lot of you got messed up with this. You actually could just stop right here. You don't have to do anything else. You don't have to split it because of that negative. Okay? An absolute value expression, if it's by itself, can never equal a negative number. This is by itself, and because it's by itself, and because this number is negative, that would mean that our answer would be no solution. Okay, so that case would give us no solution. Now let's go back to the original problem. The original problem, you cannot say it's no solution yet because the absolute value bar isn't by itself. The absolute value bars are by themselves. You have to isolate them first. And when you do that, if we actually divide by negative 3 instead of positive 3, that would change the negative 48 to a positive 16, because a negative divided by a negative would be a positive. So in that case, then we would be able to split it up because it would be positive. But on your test tomorrow, if you do see that negative and the absolute value bars are already isolated and by themselves, you have to know that it's no solution. Okay? Remember that for the test tomorrow, because a lot of you messed up with that on last week's test. So your solution will be negative 2, 2. Alright? Next we have this. We'd have to get rid of the 7 first before we could split it. That would leave you with b minus 2 equals 2. Split it. You get b minus 2 equals 2, and b minus 2 equals negative 2. If you add 2 on both sides of both equations, you'd get your two solutions, which would be b equals 4 and b equals 0. That would be your solution set, 0, 4. You'd be done. Okay, next we have this problem here. So we had to get rid of the minus 2 first. Remember, when we're solving these types of equations, typically we get rid of the addition or subtraction first. So to get rid of this minus 2, we'd add 2. Let me do this with a different color. Let's do blue. We'd add 2 on both sides. Alright, then we'd have negative 3 times the absolute value of p over 6 equals negative 2. Now we can't split it yet because we still have that negative 3 that we need to get rid of. So to get rid of the negative 3, we'd have to divide by negative 3 on both sides. And if we do that, negative 3's will cancel out, and we would end up with p over 6. Absolute value of p over 6 equals positive 2/3. Now you could go ahead and split it, and you'd have p over 6 equals 2/3, and p over 6 equals negative 2/3. To get rid of this 6, you'd have to multiply both sides of both equations by 6. So let's go ahead and do that. And if you do that, the 6's will cancel out, and you'd be left with p equals, see, that would be 4, and p equals negative 4. Oops, I forgot to write this. P equals negative 4 and 4. And the last problem on this side of our worksheet. So again, we're going to add 8 first. And if we do that, we get 4 times the absolute value of k divided by 7 equals positive 4. Okay, then we would need to get rid of this 4 by dividing both sides by 4. And if we do that, we'd get the absolute value of k over 7 equals 1. That's when we'd go ahead and split it. So this would be k over 7 equals 1, and k over 7 equals negative 1. And then to get rid of that 7, you'd multiply both sides of both equations by 7. 7's will cancel out there. That would leave you with k equals 7 and k equals negative 7. And that would be your solution set, negative 7, 7. So for these first few problems, you had to identify the vertex and then describe the transformations as related as in respects to the parent function. Okay, that's what the instruction says. So first, let's identify the vertex. So remember, vertex form of an absolute value equation, and you need to know this for your test, is y equals a times x minus h plus k, where h comma k would be the vertex. Remember, h is opposite. Okay, so if we look at this problem, what number's in the h position? 5. So, because it's a positive 5, the x value of my vertex would be negative 5. And what number's in the k position? There is no number there, so it would be 0. Now let's describe the transformation. This is all in your notes, right? This negative, you should know, would cause a reflection across the x-axis, and the plus 5 here, again in your notes, that would cause the graph to shift left 5 spaces, or 5 units, I should say. Shift left 5 units. Okay, so first let's identify the vertex. The vertex here would be, well, h is negative 3, that would make it a positive 3. And then k is negative 5. Positive 3, comma, negative 5. Now let's describe the transformation. Well, here we have a 4 that we're multiplying our absolute value expression by, and that would cause a stretch, which would mean the slope would be steeper, right? So we're going to have a stretch, and that minus 5 on the outside is going to cause our graph to shift down 5 units. So shift down 5. Make sure you can write this all down. Make sure you know this all for your test tomorrow. Okay. Next, let's start with our vertex. Our vertex here, the number in the h position would be negative 2, because here we have a positive 2. So negative 2 comma 6 would be our vertex. Next, this negative is going to cause a reflection along or across the x-axis. This plus 2 is going to make our absolute value graph, as it relates to a parent function, is going to make it shift to the left. I'm sorry about that. Shift left 2 units. And then this plus 6 would make it shift or move up 6 units. And last type of problem like this, so here we have a 1/3. Okay, so that's a number that's less than 1. It's a fraction. So because we're multiplying the outside of our absolute value bar by a fraction, as it relates to the parent function, this is actually going to cause what we call a compression, or it's actually going to be less steep. Okay, so this will be a compression. Okay, then this minus 4 would cause it to move down 4 units. And I forgot about the vertex. So the vertex here, what number's in the h position? That's the same thing as saying x plus 0, right? So 0 would be in the h position, and then negative 4, that would be your vertex. Now, let's graph these. So to graph these absolute value functions that are in vertex form, you would just need to identify your vertex and your slope. So remember, vertex form is y equals a times x minus h plus k. You need to remember that. So for number 5, remember a stands for slope, right? For number 5, what would our vertex be? Our vertex is going to be 0, negative 2. Okay. What would our slope be as we are going to the right of our vertex? That's just that number in the a position, which the number in the a position would be 1. And since it's slope, we like writing that as a fraction 1 over 1. What would the slope be as we are moving to the left of our vertex? That's the opposite of A, which in this case would be negative 1 over 1. So if we graph that, 0, negative 2 would be right here. Okay? Then as we're going to the right, which is this way, of our vertex, we'd have to use the slope 1, 1. So we'd move up 1 to the right one, up 1 to the right one, up 1 to the right one, and so forth and so forth and so forth. And we draw our line, which is a terrible line. Draw our line. That's better. Okay. Now, as we're going to the left, though, we'd have to use negative 1 over 1, which we can't go down 1 into the right one, right, because we had to move to the left. So instead, we're going to go up 1 into the left one, up 1 into the left one, up 1 into the left one. And there is the trademark V of an absolute value equation. That's it. Number 6. So, very similar to the last problem we did, our vertex is going to be negative 3, 0, right? Because there is no number in the K position, which negative 3, 0 would be right here. Remember, H is always going to be opposite, okay? And our slope, which I'm just going to write as M, as we're going to the right, it's going to be the same as our last problem, 1 over 1. And as we're going to the left, it's going to be negative 1 over 1. And you could take a look at that last problem if you're confused as to how I got that slope. Because I explained it in more detail in number 5. So that would be 1 over 1. Go up 1 to the right one, up 1 to the right one. And as we're going to the left, we go up 1 to the left one, up 1 to the left one. And that would be the graph of this absolute value function. Next, number 7. Again, very similar to the last two problems. So number 7, our vertex is going to be negative 2, 1. And our slope is, once again, going to be 1 over 1 as we're going to the right of the vertex, and negative 1 over 1 as we're going to the left. So negative 2, 1 is right here. And then we'd go up 1 to the right one, up 1 to the right one, and so forth and so forth and so forth. Or if we're going to the left of the vertex, we'd go up 1 to the left one, up 1 to the left one, up 1 to the left one, and so forth and so forth and so forth. And this would be your line. All right, now we have something else in that A position. So your vertex is going to be negative 1, negative 1. And what's your slope going to be? Well, your slope this time, as we're going to the right of our vertex, would be 2. The number in the A position is 2. Or because we like writing slopes in fraction form, it would be 2 over 1. And as we're going to the left, it would just be the opposite of that, which would be negative 2 over 1. So negative 1, negative 1 is going to be right here. Then we're going to go up 2 and to the right 1, up 2 and to the right 1. And this is when we're moving on the right-hand side of our vertex, up 2 and to the right 1. Okay? And then draw your line. But if we're going to the left-hand side of our vertex, we'd go up 2 and to the left 1, up 2 and to the left 1, up 2 and to the left 1. And draw your line as straight as possible. Okay? Next, number 9. We have a negative here, so that should automatically tell you that this is going to be reflected along the x-axis. Your vertex is going to be positive 2, 3. Now your slope, as you're going to the right of the vertex, that's negative 1 over 1. Okay, and as you're going to the left, it would be the opposite, so it would be 1 over 1. And hopefully that makes sense because this graph is going to be pointing downwards, right? And that's because of that negative, and that, or it's going to be reflected across the across the x-axis, and that's why our slope is negative as we go from our vertex to the right. So your vertex is 2, 3, which is going to be right here. And then as we go to the right, we are going to go down 1 into the right one, down 1 into the right one. And that would be your line. As we go to the left, we would go down 1 to the left one, down 1 to the left one, down 1 to the left one. And that would be your line for that part of this absolute value graph. And last one, Your vertex here is going to be 0, -3. Your slope as you go to the right of the graph would be 1/2. As you go to the left is going to be -1/2. So if you graph that, 0, -3 is going to be right here. We would go up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. Okay, less steep than our parent function. Or we would go up 1 to the left 2, up 1 to the left 2, up 1 to the left 2. And again, less steep than our parent function. And make sure that you know what the term vertex means. For this test, make sure you look over the definition of absolute value as well. You would need to know that for tomorrow's test as well. Also, make sure you know what the parent function of a linear equation is. You will need to know that for your test tomorrow. So for linear, it's y equals x. For absolute value, it's y equals absolute value of x. And I've been telling you this all week. This is going to be on your test, so make sure you know all of this. And that's your test tomorrow. Okay, so good luck. I'll see you tomorrow. Have a great day.